All right, hello everybody and welcome. Okay, it's May 7th, and basically the things that I said that are very important so far are on my Google Classroom. Go to this AP coronavirus updates thing that I posted. That's going to bring you right to this. Go through this for all of your AP exams. Has very, very important information. You want to confirm your email address to make sure that you're going to get it. You're going to get your e-ticket with you know, all your information. That will be 2 days before the exam. So that's going to be on Sunday for us because our exam is on Tuesday. You know that you're going to check in 30 minutes early. So our exam starts at 11 a.m. on Tuesday. So that means that you're going to check in, or sorry, you know, log in and do that at 10:30 a.m. is when you're going to be. Anyway, this has all the information about all your AP exams, not just for us.
Again, today,
for
to bring along
AP calculus specific, they go through you know, this, which is a very informative little piece.
said the debrief will likely happen tomorrow of that FRQ2.
Play it for you right now.
Haven't already? Right? We can still say do this today, but definitely practice your uploading solutions procedure. Make sure that you have decided exactly what form that you want to do that.
Anyway, he goes through these things. There's 5 steps. I'll go through those in a little bit, but this is what I really wanted to get to was this.
Submission processes. And we encourage you, watch yesterday's video if you haven't already, and then you can even go back to Tuesday and you can watch the whole upload process that we explained in great detail at that point. So, all right. I think we're debriefing.
Sorry, let's go back. So that was actually Tuesdays, which is right here. This is when he...
And that they're able to this year add some things that might help you. And so this might sound a little bit different than what you've heard before, but it's only because the College Board.
So basically what he's going to say here is, okay, there are 2 main ways to upload your answers. One is through a text file. So when he says text file, basically there are ways that you can do that where you're on either a Google Doc or Microsoft Word or something like that, and that's how you're like in your answers. You can, or he's also saying there are some like tablets and some you know, programs that you can write on there and then kind of send those, but they have to be, this is an important thing, one of these file types. Okay, so there's a PDF, there's you know, Doc or DocX, which are Microsoft Word, but anyway, it's got to be one of these file types. So verify that if you are going to do it that way. What he also says is this PDF, that could be you handwriting, you know, doing the problems on a sheet of paper, and then using like Cam Scanner or even in notes on iPhone, but you know, whatever it is, you can scan your stuff and save, you know, save that as a PDF and then upload it that way. That is an option for you. Personally, for me, I go to this attach a photo. So I have my work on my pages, my just pieces of paper. I then take a quick picture, email it to myself. And when I do, remember for the size, I go medium. Not actual size, because that takes longer because it's more data and they don't need that. You know, high quality of a picture in terms of the pixels and all that. So just medium is fine. And then I get it right away and do it that way. So that's what I would recommend. But anyway, he just goes through and says, hey, for those writing on a sheet of paper, what they now allow that initially they said they weren't sure if they were going to be able to accept it was scanning that, putting that in a PDF and then uploading the PDF. But now they said that they can do that. So that's why he explains in this video that they just added that. Anyway, let's go to the other, this AP checklist. So cb.org/AP checklist. Oh, this is the AP demo. So this kind of goes through, again, this is not calculus specific, but this just goes through if you wanted to print this out, right? Once you get your APID, your 8-character APID, you can put that in here. Name your exam, all this stuff. Am I ready to test? So this just goes through some basics. The one thing that I saw here is the browser. It says opens in Chrome, Firefox, Safari, or Edge. The exam will not open in other browsers. So if you're still using like Internet Explorer or something like that, you need to practice. That's why the even the cb.org/AP demo is good, because that is specific to certain browsers as well. And so make sure that you have practiced that, so you're not surprised at 11 a.m. on Tuesday because you're not seeing anything when you should be, because maybe you're using another browser. So anyway, just go through. This is the other thing, which is, like I said, the AP checklist. And then what was the other thing was, oh yeah, this is just a video, this AP 2020 exam rules. So let's go to that. So this is a little video, and it's pretty quick. As this is playing, I'm gonna let this play because I left my
This year, you can take your AP exams online. Here, we highlight the rules, including what Open Book Open Notes means, what you can and can't do on the internet, and what we're doing to ensure fairness. The exams will be Open Book Open Notes, so you can use resources from your class or teacher, such as your textbook, class notes, study guides, previous assignments, or previous exams. But you can't consult with anyone during the exam, including other test takers or family members. You can search the internet during your exam, but we strongly advise against it. The information won't be helpful for your responses, and searching will waste valuable time. You also can't use sites or apps like Reddit, Discord, or any social media platform to share information or collaborate with others during the exam. You can use digital docs such as Google Docs, but they must be private or downloaded to your computer to ensure no one else can see your work. All your work must be your own and will be reviewed using a variety of methods, including digital security tools to detect plagiarism. Your teacher will also have a chance to review your work and let us know if there are any inconsistencies. Any student who gains an unfair advantage will have their scores canceled, and the incident will be reported to their high school and college admissions offices. Just remember, the AP exam rules are designed to ensure you and all students can show colleges how much you've learned, and we can't wait to see that. For more details about the rules and test security, go to cb.org/AP 2020 rules.
Okay, so I hope that was informative. I don't know if you've already seen that, but here's how I would be feeling if I were you. And maybe you can say, not really, or yeah, I feel like not just myself, but there are a lot of teachers that are probably throwing a whole bunch of stuff at you about resources. Oh, did you see this? Did you do that? Did you do all of that, right? And it's tough to say, okay, what do I actually need to do? I can't do absolutely everything that everyone's throwing at me. Are you guys feeling that way? Plus trying to plan time to prepare for the exam by actually going through the content and all that. Anyone want to speak to that or chat it up about that?
I agree. There's a lot being, as far as I appreciate it, but a lot of my teachers are throwing a lot of different resources my way. It's a bit much.
Yeah, so here's what is tough for us. Obviously, we don't see you every single day, but we want to give you the information that we think is going to help you, right? And so, plus, the thing that's difficult is like right now, there are 19 of you here out of the 34 students in my class. So, you know, I look at that and I say, okay, 15 people, almost half the class is not here right now. I can't do anything about that, right? So that's why what I have been doing is trying to put it here, record it, put it up. But I look and I have maybe 3 views on my on the videos, and there's a lot more than 3 people not in the session. And so then I put it on my Google Classroom. So if you are going to everything, you might be getting the same information kind of multiple times. But I just want to make sure all my students get the information, because of course, going through like practicing the process of uploading your answers, that's very, very important. That's not, you know, important in terms of the knowledge of calculus, but that's important in terms of getting the grade that you should deserve, or that you deserve, because you know how to do it and you've practiced uploading, taking the picture, emailing it to yourself, and then uploading it, you know, in that finite amount of time. So, and just the rules, what's going to be on it, what are the different types of problems and all that. So we're trying to give you the information that we think is going to be the most beneficial. But by all of us, I realize that it's difficult to, you know, process like, okay, well, what do I really need to do? Let me tell you, here are the important things, like from start to finish, what I think are, you know, you need to focus on. And I'm actually going to write this down so I can post it. Why did I just get a sheet of paper out? Like I should write it. Okay. Here we go. You know what? I don't need this anymore. I'm gonna get rid of you and then add a new page. And it just quit out on me. Awesome. Maybe I should have just written it down in the first place. Anyway, number 1, what I think is the most important to focus on right now is the process. So all of the logistics about the AP exam. Verify that you have you know, that your email is like AP Classroom and all that, so that you will get the information from College Board when they send it to you, okay? Which if you've already been getting the communications from College Board, then you know that you're good. Okay, what to focus on. And I should put that today is 5/7/2020. Okay, what to focus on. Number 1, the AP specific information, including upload. Okay, so I've put, in fact, that going back to this, the this guy right there, 5 steps to get ready. I think that kind of is a good you know, spot to start and do what they tell you to do. Like, for example, review the ways to submit, launch the interactive exam demo. So go through that. So I'm going to put this. Put that in there. Bam. That's number one. Number two, for AP Calculus, that should be a capital T. So the YouTube videos, especially the review problems, or I should say, you know, AP practice problems. Okay, so make sure that you go there and, you know, focus on the review problems, the practice problems, and that's kind of what we're gonna, you know, start with today. And then three, this is where you're identifying what you need, you specifically need extra work with or practice with. So work through or watch. Again, this could be on Khan Academy or this, you know, the AP Calc BC YouTube channel. Watch videos on concepts you struggle with. Okay. I know that's not grammatically correct because I ended with, but anyway, you're going to go through, that's what I would focus on if I were you. AP specific information. So from this website about, you know, the uploading process, the time, you know, making sure that you get the email 2 days before. Make sure that that has your AP ID in it and all that. Make sure that you note that you're logging on and ready to go at 10:30. What should you have in front of you at 10:30? Have, you know, with your phone charged if you're taking the picture with your phone, and, you know, obviously computer charged and all that stuff. Everything that they go through in this is good. Next, all of these review problems I feel like are very, very good, and they do a solid job. You can fast forward through this stuff where they're giving the t-shirt giveaways and the, you know, all that. They're just being funny or joking around a little bit, and get right to the content because they are about an hour each. And then identify, oh man, yeah, I don't really know. There was a Taylor polynomial problem, right? And I kind of forgot that. Well, I'm going to go through that today, but like maybe you could go and look through those videos or do problems specific to those concepts that you're like, you know, seeing that you're having difficulty, you know, answering problems with those concepts. Anyway, that's my focus right there. That's what I would do. These three things. So I hope that's more of like a narrowing down. I'm just giving you a bunch of the, you know, resources that you can go to, but this is really what I want you guys to focus on. Okay. Before we get started, and I'm going to go through the answers for the longer problem, which is problem number 1, where you have 25 minutes to do the problem and then 5 minutes to upload it. But before I get to that, are there any generic questions on this exam or that you have for me or anything about it? I guess.
Do you have to find out about the number of tabs?
So I've looked everywhere on that, and that video that I just showed did not state anything about number of tabs. So I haven't found anything. Has anybody else looked into that or tried to find information about that? So Kayla, I mean, I will, I'll make a note again and, you know, keep researching. There are a bunch of teacher discussion boards and all that that I'll that I'll dive into and see. But again, do you remember where you heard that or when you heard that?
Okay. Yeah.
Did you say something?
Yeah, sorry, I said okay, thanks.
Okay, do you remember where you heard that though about the tabs?
I don't remember. I think it had to do with like you can have like 2 tabs side by side or something, and I just wasn't sure if I would like need more tabs for uploading the photos or something, if that would be an issue. But
Got it. Yeah, I'll dive in, you know, more. But again, I've watched, I believe, every single thing that's come out from the College Board, and I can't remember ever seeing anything about limiting the number of tabs. So, okay, so now that we are kind of ready to go, how many of you guys watched that video and did the problem number 1 that they put up there for the 25 minutes and then the 5 minutes of uploading? Maybe can you raise your hand on the so maybe I only see 2 people who have raised hands.
I completely forgot about it. I'm probably not the only one.
Okay. So, well, that's what I'm going to be going over right now. So, I'm a little bit torn. Well, whatever. We're going to be doing it. So listen, here's what they've done. Okay. So let's now look at these videos that I said I think are very, very valuable. There's only one video remaining, and that's tomorrow. Again, they're going to go through more exam tips and best wishes, but they're also going to be going over, I believe, the problem that they gave today. This is today's video, video number 32. 31 was yesterday. They say timed AP exam practice number 2, but it was actually problem number 1.
And teachers, but they couldn't do those
So
things.
what they did is
That's why you're all here, and
they gave this problem. I'll move this over here now. They gave this problem, and so I'm just going to pause it. And what they did is they gave 25 minutes for you to work on it. And during the 25 minutes that they gave, they were basically quiet, and this was counting down from 30. So I'm just gonna let you know my experience with it. So I took this and I made a note. So I don't know, because they had an issue with their clock. You'll kind of see if you go back a little bit. So their video was over the clock for a bit of it, and then they removed it, and you're like, oh, good. But then it came back and it was covering it, and it was kind of messed up. It was like paused here for a bit, and then it went to like just a little bit further. It went to, you know, so I don't know how accurate their time was, is what I'm trying to say. And then they stopped it. Anyway, this is, I was able to finish it with like right around here. So what I said is there were 8 minutes remaining. which really means that this problem took me, and again, I wrote out everything, and I kind of I knew what to do, but I was kind of writing slowly and neatly so I could maybe share this with you guys and, slow myself down. So I'm not just trying to do it super, super fast. And with doing that, it took me basically 22 minutes to do all of the different parts. Now this is another thing. This is coming from them, which, they had been writers and all that of exam questions. So what they think for question number 1, being something that is going to be a longer question, they did go all the way through G. So they had A, B, C, D, E, F, G. So that's against kind of what I was thinking. I'm like, I think they might only go to E. Here they went 2 beyond that. So is that how it's going to be on the AP? Nobody knows, right? These guys don't know. They're just throwing problems out that are kind of their best guesses. So for me, it took me 22 minutes to get through the 1, 2, 3, 4, 5, 6, 7 different parts of this question. And so that's kind of what I wanted to go over with you guys today. I'm a little torn because only 3 of you raised your hand saying that you did this problem already. How about this? I'm going to go over this problem tomorrow, starting at 9 a.m. I'll have a Zoom session, and I'll go over this tomorrow, which is Friday at 9 a.m. But right now, how about we do this? Let's go to today's
It's really kind of
video that they just uploaded. They started this live at 6 a.m. our time. And they did give another, so they went through the problem from yesterday. So I'm going to go through that. But then they gave another timed practice problem. I haven't even looked at this yet. I just went through the answers to make sure that I got everything right. And so I haven't even looked at this timed practice for 15 minutes, but how about we do that right now? I think that'll be a good use of our time. Did anybody, so chat if you did, so only if you watched this video that was just posted this morning, if you did this practice problem, if you did type that into the chat now that yes, I did that. If you didn't, you don't have to put I didn't. Okay, so I don't see anybody that typed that in. So let's go through this. Okay, this is something, like I said, I didn't get to this part of the video. I haven't seen this. So let's just.
That's not a really great way to go about things because that's just one time. You want to practice it multiple times until you no longer ever make a mistake.
He's talking about the upload process. Practice it many times so you don't make a mistake.
You want to practice it until you do it right 3, 4, 5 times in a row. That way, you know when the exam time comes, you've got this down pat. You know exactly how long it takes to upload things. You're not going to panic. If something goes wrong, you can pause, kind of collect yourself and troubleshoot, right? So make sure you practice this multiple times in different ways to make sure everything's going to work out the way it's supposed to work out, right? So here's the question we're going to see today. It's a timed FRQ problem. You've got 5 parts to it.
So let's look at this. I will actually bring this to oh, bummer. So we are going to do this process, and sorry, let me just get this set up so that we are good. This is obviously different than what I expected to do today. I wanted to go through the one from yesterday, but we're doing this guy instead. All right, this E is going to be down here. And the graph is going to be here. So, as we've kind of been preparing, right? I've talked about the different types of problems, and it sure seems like this being, you know, a graph. I think that's something that we're seeing is probably likely is that they're going to give us maybe functions, but also you know, tables of values and graphs. So here we go. Let's kind of check this out. So they say the graph of f prime, the derivative of the differentiable function f, consists of 5 linear segments. So 1, 2, 3, 4, 5, and a semicircle, and is shown in the figure above. So this is f prime. The functions f and f prime are defined on the closed interval from -5 to 10. And it is known, so they give us an initial condition here, that f of 6 is equal to -1. So it says part A, and let's maybe, this is gonna be tough for me to time you and do this because it's like this. So let's go kind of part by part, okay? So let's time ourselves. Let's say for part A, we're gonna give ourselves like 3 minutes or so. So let's try to focus on part A, about 3 minutes or so. It says, find the minimum value, that's the y value, of f on the closed interval from -5 to 10 and justify your answer, okay? So let's go ahead and do that. Right now I have that it's 11:13. Hey Siri, set timer for 3 minutes. Okay, we got 3 minutes. Go ahead and start for this one. Okay, your 3 minutes is up. Let's talk through this a little bit. Somebody give me, just their thoughts on how to even approach this problem, because sometimes people look at this and like, I have no idea where to even begin. So help us out, guide us a little bit. What do you think we need to focus on in order to just get us started?
The closed interval method.
Okay, so we're looking at the closed interval method. And so basically what it's saying is we're looking for the minimum value of f on the closed interval from -5 to 10, right? Okay, so f could potentially have extreme values, meaning mins or maxes, for all of the values where the derivative is equal to 0, undefined, or at the endpoints, meaning at the critical numbers and the endpoints of that interval, because we have a closed interval. So let's think about it. For f, we have that a function is, because f prime is given to us, this means that f is increasing, right? Because f prime is positive. Does everybody see that f prime is positive here? Which indicates that f is increasing. So with whatever, so f of -5, I don't know what that is yet, right? But I do know that for the values of x after -5, meaning to the right of -5, -4, -3, -2, -1, all the way until 0, I have that f is increasing, increasing, increasing. Would there be a minimum value at 0? That's a critical number, right? But would there be a minimum value there for f?
No.
No, there could be a local max, which could be an global max there, but not a min. And we're looking for min, right? So then we have from 0 to 4, we have that f prime is negative. So right here, so we have that f is decreasing. And then we have another critical number here. But at this critical number, when x is equal to 4, the function f goes from decreasing back to decreasing. Do y'all see that? And so there wouldn't be an absolute minimum value there, because whatever the value was there is going to be greater than what the value is here, right? Because you have a value and then it's decreasing after that, so you're decreasing in values. So anyway, from here, we have another critical number right here, right? And then here we have f is increasing until your endpoint, right? So f of 10. Okay. Is it possible that the absolute minimum value is going to occur at f of 10? Meaning at x equals 10. No one's answering that, so I'll answer it. So
Wait, you asked what to do from here? Is that what you said? I was something
No.
that went on.
I said, is it possible for this function f to have a minimum value, that f has a minimum value at x equals 10?
No, because we know that f at x equals 10 is going to be greater than f of 6 because it increases after f of 6.
Good. So one person might say, well, yeah, because it's an endpoint. Okay, that's valid. However, because we know that the function f is increasing up until 10, there will not be a local or global minimum at x equals 10. Okay? So for me, when I'm looking at this, the main points that I've already identified as being possible global mins are or occur when x is equal to 6. So this guy is definitely a good candidate. 10 doesn't make sense. 0 doesn't make sense. 4 doesn't make sense. And this is the other candidate. Do you see why? I have whatever value this is. Let's just give it a value. Let's say my favorite number is 23. I'm just gonna say, what if this were 23 right here? So from 23, it's now increasing until there. So this is when it's gonna be like much greater than 23. And then decreasing there. And then from that point, increasing until there. So at x equals -5 and at x equals 6, those are my only possible places on this, given that this is the graph of f prime, where f would have a minimum. Well, we already know that f of 6 is equal to -1. Right? F of 6 equals -1. So my question is, what is f of -5? So what would we do here? Well, we would have to back it up, right? So basically what we're saying is f of 6 equals f of -5 plus the integral from -5 to 6 of f prime of x dx. What in the world am I doing there? Why am I putting that down? What's going on? Somebody. I'm just gonna go. Where you are equals where you were plus how much you've changed. So the value of f at 6 is equal to the value of f at -5 plus how much f changed from -5 to 6, okay? Well, we know that I think I just moved that down. There we go. So we know that f of 6 is -1. So I would say that, you know, okay, that's -1 equals, I don't know that, but, and I have to look at the graph in order to do this guy right there, right? So let's do that. Let's focus on maybe, so this guy is the integral from 0 to, sorry, not 0, from -5 to 0 of f prime of x dx plus, and why am I focusing on that? Because that's just going to be that triangle that lies above the x-axis there. And then I'm going to focus on this semicircle that lies below the x-axis. So that's going to be the integral from 0 to 4 of f prime of x dx plus, and then this right here is going to be the integral from 4 to 6 of f prime of x dx. So let's look at this first one right here. What is this area right there? Well, that's 1/2 times 5 times 3. So that's 15 halves. Oops, I went too far. So this guy is 15 halves. The next guy from 0 to 4. Well, that's a semicircle, right? So when I'm looking at this, that has a radius of 2, and it's a semicircle. So remember, it's going to be pi halves r squared. So pi halves times r squared. Well, that's just going to be 2 pi, but if I put 2 pi, that won't be correct, right? What do I need to put? Are you guys with me? The integral from 0 to 4 is pi halves r squared, which you could say, oh, that's 2 pi. Thank you, William. It's negative 2 pi because it lies underneath the x-axis or below the x-axis. So negative 2 pi. And then right here from 4 to 6, we have that little triangle, again, that lies below the x-axis. So we have, that is 1/2 times the base, which is 2, times the height. So that's going to be negative 2 right there. So let's bring that. So altogether, I have that f of negative 5 is 15 halves minus 2 and minus 2 pi. So 15 halves minus 4 halves is 11 halves minus 2 pi. So you can plug that in. This right here is 5.5 minus 6.28 something. So this will be less, greater than negative 1, right? Someone do that for me really quickly. It's going to be negative point something, 7.1 something, I think. What is that? Negative 0.783. Thank you. Negative 0.783. So you're comparing negative 1 and negative 0.783 for the absolute minimum value. Well, the absolute minimum value is negative 1. Does that make sense? So that's part A. Part B. So I'm not going to bring this stuff down. Part B, it says, let g of x equal sine of 3 minus f prime of x. Find g prime of 6. I'm going to bring this down along with the graph so we can see both of those. So we're finding g prime of 6. And the graph is going to be just this guy right here. Okay, so work on part B. It should only take you maybe 2 minutes. Hey Siri, set timer for 2 minutes.
Your timer is set for 2 minutes.
Thank you.
2 minutes and counting.
Okay, so that's been 2 minutes. So let's check it out. So G prime of 6. So the first concept that they are checking here or testing is that you know the chain rule, right? So the derivative of sine of anything is cosine of that thing times the derivative of what's inside. So for sine of 3 minus f prime of x, the derivative of that, which I'm calling g prime of x, is cosine of 3 minus f prime of x times the derivative of what's inside, which is negative f double prime of x. Okay, so then when we plug in 6 in for x, we get that g prime of 6 is cosine of 3 minus f prime of 6. Let's go up really quickly. This is a graph of f prime, so at 6, we're at 0. Does everyone see that? So I'm going to put 0 in for this guy times negative f double prime of 6. F double prime of 6 is the derivative of f prime of 6, meaning the slope right here. I go up 2 over 1. So right now, the derivative of this line, which is f double prime of 6, is going to be 2. But this tells me it's negative that. So this is going to be negative 2. So I would say that g prime of 6 is equal to cosine of 3 times negative 2. So I should say negative 2 cosine of 3. Now make sure your calculator is in radian mode. If you are going to plug that in to give a decimal approximation. However, this will suffice. This is good enough for your answer, okay? Because that is mathematically correct. Okay. Now, little Euler's method problem for you. Well, first of all, before I move on, are we good with that, with part B? Just a chain rule, but also looking at the function and identifying that f double prime is the derivative of f prime. Okay. All right, so let's look at C, part C. It says, let h of x be the particular solution to the differential equation dy dx equals y minus f prime of x over x. So they're trying to be a little complicated here, but this is the differential equation that they give us. Okay, so this is for y equals h of x. So there's another function, y equals h of x. And that is the particular solution to this differential equation that involves y and, so y is also known as h of x, and f prime of x, okay? So, Euler's method. Bum, 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 bum. This is my differential equation. And this is my initial point. Okay. And so I'm going to actually put this down here. So dy dx, so I can have more space. Dy dx equals y minus f prime of x over x. H of 5 equals 6. They want us to start at x equals 5, 2 step sizes, and approximate h of 3 is approximately what? Okay, so here's what I'm going to do. Actually, do you want some time? Actually, let me just dive in. I'm gonna dive in. Sorry if you want that, but here we go. So I'm gonna say, okay, n x sub n y sub n, and again, this comes from the h from y equals h of x, and then dy dx evaluated at x sub n, y sub n. So okay, sorry, 0, 1, and it's going to be 2 steps. My initial x value is 5. My ending x value is going to be 3, so this is going to be 4, 3, which tells me that my step size, which I usually use h for that, but I'm not going to here because that's they gave us the function h of x, so I'm not going to use h. I'm just going to call it step size. Is what? What is the step size for this problem? If we start at 5 and we're going to 3 with 2 steps. Good, -1, not 1, because we're starting at 5 and we're going backwards, okay? So this is going to be -1 right there. So that's my step size. I'm gonna put that just as like my thought, right? My initial y value, they told me was 6. And so here we go. Let's first find the slope. Well, dy dx is equal to y, so the y value, which is that, minus f prime of x. Well, in this case, x is 5, so I got to use this graph. So that one's a little tricky, all over x. So far, here's what we know. We know it's going to be 6 minus something divided by 5. Do you see where that y is that, and that x is that, and the y is this y value, and the x is this x value? So that's where that comes from. And then the thing that is tough for this, that's different than what we've usually seen, is they throw f prime of x into that. Well, when x is equal to 5, what's f prime of 5? Let's go back up to this. This is f prime, right? The graph of f prime. F prime of 5 is -2. Do y'all see that? So this guy is from the graph. You guys see that? So that's an extra little twist. Remember that AP little twist that they kind of give you? We've never seen a differential equation for one function, h, that has in it the derivative of another function, f. We've never seen that before. I've never seen that for any problem before, but we were able to do it. So anyway, 6 minus -2 is 8 divided by 5. So this whole thing is 8/5. Okay, so now I know my step size was -1. I've already taken that into consideration to get my new x value. So now I need my new y value. But remember, this is the big thing about Euler's method, right? Is y sub n plus 1 equals y sub n plus dy dx evaluated at x sub n, y sub n, times the step size, which I usually call h, but again, I'm not going to do that for this problem because h is a function. So my next y value, which in this case y of 1, so y of 1 equals y of 0 plus dy dx evaluated at x sub 0, y sub 0, which I've already calculated, times -1. So plugging in what I know, y sub 1 is equal to y sub 0. Let's go up to that. Y sub 0 is 6 plus dy dx, which is 8/5 times -1, also known as 6 minus 8/5, which is, so let's change that to 30/5. So this is going to give me 22/5. That's my new y value, 22/5. Okay, now let's go and find this. Well, we know that the differential equation is the y value minus f prime of 22, or sorry, f prime of 4, I should say, f prime of 4, which we'll look at in a little bit, all divided by the x value, which is 4. So again, this is the x value that goes there. This was the y value that goes there. And so to find f prime of 4, I have to go back up here. This is the graph of f prime. So what is f prime of 4? 0. So this whole thing is just 22 over 20 or 11 over 10. Okay, so now when we go down to this, we have, okay, y of 2, let me actually put it maybe over here. Y of 2 equals y of 1 plus dy dx evaluated at x of 1, y sub 1 times step size. Okay, so y of 2 is equal to y of 1 is 22/5 plus my dy dx is up here 22/5, sorry, 11/10 times -1. So y of 2 is equal to, let's turn that into 44/10 minus 11/10, also known as 33/10. That's what I got. That goes here. Were you guys able to follow that? Cool. Okay. I know we're getting pretty late. Let's just talk about the next couple really quickly. It says for t in between 0 and 10 seconds, a particle moves along a horizontal axis with velocity v measured in meters per second. Evaluate the integral from 0 to 10 of the absolute value of v prime of t, and v is just f prime. Okay, so if v is the velocity, before I even try to do anything, if v is the velocity, what does the integral from 0 to 10 of the absolute value of the velocity give us? Actually, before you answer that, what if the absolute value marks weren't there? What is the integral from 0 to 10 of the velocity function with respect to time? First, answer that question. So imagine the absolute value marks weren't there. The integral from 0 to 10 of the velocity function is equal to what?
Without the absolute value, it would be the displacement from t equals 0 to t equals 10.
Correct. So without the absolute value marks, it would be the displacement from t equals 0 to t equals 10. With the absolute value marks, what is it?
The distance traveled regardless of what direction.
The total distance traveled. So remember when I acted like a fool and I got up there and I said, okay, I'm going to take 3 steps this way and then 2 steps this way and then 1 step this way, right? Well, if you were to go positive 3 steps, back 2 steps, and forward 1 step, your displacement would be positive 3, 2, 1, 2. That would be your displacement, right? Positive 3 minus 2, which would put you at 1, plus 1 would put you at 2. So your displacement would be 2. But your total distance traveled would be 3 plus, so absolute value of 3, which is 3, plus absolute value of -2, which is 2, plus absolute value of 1, which is 1. So it'd be 3 plus 2 plus 1, which is 6. That's what they're asking here. You have an absolute value of the velocity function, which is the total distance traveled. So what you could do is go up to here from 0 to 10. So from 0 to 10, this is positive. You would find this area, make it positive. Find this area, make it positive. So this area positive plus this area positive plus that area, which already is positive, you would add together and get the total distance traveled. Okay, so that's how you would do that guy. I'll save that, but that's basically what you would do, and that had the meaning using correct units. What are the correct units? Well, if this is in meters per second, the total distance traveled is going to be in meters, right? Okay. So this guy's good. Ba-ba-da-da. Let me just get you started with this. And then tomorrow at 9 a.m., I am going to be going through the problem that they put on yesterday's the problem that they gave yesterday on the AP Calc VC YouTube channel. Okay, that's what I'm going to be doing tomorrow at 9 a.m. Which, by the way, as after I like, okay, I finished and I turned in my work and everything. I didn't really turn it in, but I'm like, okay, this is when I would upload it. I then was looking back through and I would have gotten a point off, and I'll explain that to you tomorrow. I put something initially on my work, but as I was going through, when I like boxed my answer, I didn't include that in my box. So I don't know if that makes you, you know, if you're glad to hear that, or if you're like, this guy doesn't even know what he's talking about. But anyway, okay, so here we go. We have k of x is equal to this guy right there, 2x minus the integral from 6 to x of f of t dt. And it asks us to write the third degree Taylor polynomial to k about x equals 6. So before I'm going to ignore this for now, and I'm just going to write what the third degree Taylor polynomial would look like. Sometimes they put t sub 3 of x. Sometimes they put p sub 3 of x for polynomial. It doesn't really matter. P sub 3 is the third degree Taylor polynomial. T sub 3 is the third degree Taylor polynomial. So it doesn't matter notation wise. I think for you guys, I usually did a t there. So let's go ahead and do that. So this is equal to, so regardless of what k is equal to, this is what it's going to be. It's going to be k of 6 plus k prime of 6 over 1 factorial, which I don't need to write, times x minus 6, plus k double prime of 6 over 2 factorial, which is just 2, times x minus 6 squared, plus k triple prime of 6 over 3 factorial times x minus 6 to the third. So this is important that you remember the nth degree Taylor polynomial form, right? So here they gave us a function k. When I taught it, it was the function f. So I did f of a plus f prime of a times quantity x minus a plus f double prime of a over 2 factorial times quantity x minus a squared. And I went from there, but now it's the function k that they're looking for. So this is how I would write it. Okay, so now what is k of 6? Well, when I plug 6 in for k, this is what I get. So what is k of 6? 12 is correct, right? Because when you plug 6 in for x, right, because k of 6, that's 2 times 6, which is 12, minus the integral from 6 to 6 of f of t dt. Well, that's just going to be 0, so it's going to be 12. So this is equal to 12 plus, and now I have to look at this. So when we look at concepts that they're teaching, or that they're testing, I should say, what we're looking at is, gosh, this guy always gets in my way. What we're looking at is, okay, k prime of x is equal to, so you tell me, what is k prime of x?
It would be 2 minus f of x.
Correct. So that means that k prime of 6 equals 2 minus f of 6. Well, guess what? They gave us what f of 6 was, right? Way up here. Oops. F of 6 is -1. Hey, that was kind of them to give us that. F of 6 is -1, right? So k prime of 6 is 3. So now let's talk about k double prime of x. What's k double prime of x?
Negative f prime of x.
Correct, negative f prime of x. So k double prime of 6 equals negative f prime of 6. So what is f prime of 6 going up here? F prime was given, so f prime of 6 is 0, right? Because this is f prime. So f prime of 6 is 0. So this whole expression is going to be 0 because this was 0 over 2 times x minus 6 squared, so that's 0. So then I go to the third derivative. So I need, again, to do this. Let's go back to red. So what is the third derivative of k with respect to x? Negative f double prime of x, right?
Negative f double prime of x.
Cool. So k triple prime of x is negative, sorry, not x, of 6 is negative f double prime of 6, which is, so let's go back up, f double prime of 6, again, is, if this is f prime, it's the derivative of f prime, which in this case is 2. So that's 2. F double prime of 6 equals 2, is what I'm just saying, right? Because it's the f prime of 6 is 0, but the slope of this, which is f double prime of 6, is 2. So here we go. So this is just -2. So when I go up here, I'm going to say, first of all, move you one more time over here. And I'm going to say, so k triple prime of 6 is -2. So this -2 over 6 times x minus 6 cubed. You can leave it just like that and call it, let's say, t sub 3 of x. Okay. Now, yes, you could say, well, Mr. Broler, can I just say 12 plus 3 times quantity x minus 6 minus 1/3 times quantity x minus 6 cubed? Yes, you may, but you do not have to simplify. But that's what we got going on, okay? All right, cool. Any other last minute questions before I let you go? And we reconvene tomorrow at 9 a.m. for the longer, the 25-minute question. No other questions? You guys good to go? All right, people. Again, I just want to reiterate, don't get overwhelmed. Focus on the AP specific info that was on my, I posted in Google Classroom, which is right there. Practice uploading. Practice. In your AP ID for the, cb.org/ whatever that was called, AP upload or whatever. You're gonna put practice in there, and then you're just gonna take pictures of, whatever work, and then just go through the process of taking the pictures, emailing to yourself, getting from your email, and then putting the pictures up one at a time, remember? Upload the pictures one at a time. Next, go through these videos that they've been posting, especially the review problems, and then the AP practice problems. Those are very, very good problems and good videos. Just, they're informative about, this stuff as well. And then you're going to identify what you focus on. And then you're going to go through those and, do the videos on what you're struggling with, or Khan Academy, or, on the AP Calc BC YouTube video, whatever it is, that's what you're going to do. Okay. So this is what I want you to focus on. Please do that. And by tomorrow at 9 a.m., I really want you guys there tomorrow at 9 a.m. Also, we need to discuss about meeting on Monday and what time everybody can meet on Monday, because our meeting time on Tuesday is when you're logging in to take the test. So I want to meet one more time at least, so that would maybe on Monday to work through everything. That could be later on, like 3 or 4, whenever you want to. So start thinking about that. We'll discuss that tomorrow when we meet at 9. Okay? Anything else? You guys good?
Most of us have the AP Gov test at 11 on Monday, so we'd have to do it later or earlier or something like that. Just so
Yeah,
you
and
know.
I'm totally good with that. I could do it, anytime. Could be in the afternoon, after your exam, 2 or 3, or it could be 5 or 7, or whenever you want to, whenever most of you guys can meet, that's when I want to make it happen. All right? Cool. Think about that. We will reconvene tomorrow at 9 and have that longer problem done by that point, so we can do that. Man, I'm sitting and I'm not used to sitting and I don't like it, but we're good. All right? Cool, guys. Have a great rest of your day. Do that problem. Maybe right now, go and do it. Maybe have some lunch, then come back to have that ready to go by 9 a.m. tomorrow. Cool. Working. I'll see you guys tomorrow.
Have a good day.
Bye, you too.